could be a hash table or whatever, and you systematically apply a specified function to each element of that set. And this makes use of, map makes use of, or serves as an instance of a higher order function. Why is that? Because it makes use of what as arguments?
Function as an argument.
Function is an argument in this case, and in general, if we're dealing with high order functions, we also use that term to denote a function that returns another function, for example. It could take, return, or both other functions. We call that a higher order function. There's other terms for it as well, but that's a familiar term from the programming language context. Okay, so how did you use map within the context of that exercise then? Let's say for the case of reading in a file, what's one way to use map?
Converting characters to integers.
Characters to integers, that's right. So all the characters that are present when you read it in can be systematically converted to integers, and then they can be, in a less deep way, they can be reshaped into a 2D array. And that's what you're going to be exploiting in the problem set. Okay, so that's good. How about in terms of writing out the file? Where would map apply there?
The same process, but in reverse.
Same basic process. For each successive row of that file, you might map them to values that are stars and spaces, right? And put them out accordingly. So that's good. I'd like to show you my code that addressed this problem, so you can get a sense of how it works. Before I do that, we're trying to figure out this AV issue, but I wanted to comment a little bit on an element of this that you will see elsewhere in other programming languages, even outside the programming language or the functional programming language context, which is something that's known as the Fluent Style of programming. Does anyone know what Fluent Style is? Has anyone heard that? Heard of that term? Okay. So when you have a programming language that has functions, methods, returning values, often it's convenient to write expressions that consist of successive functions within that programming language. So you might have an object A, you have a reference to it called A, and you call some function on that, maybe it has some arguments, and that returns perhaps a reference to some other object, and you'll call G on that, maybe that has some arguments as well, and call H on that, etc. You've seen this before, presumably, many times. Sometimes known as Fluent Style. And the important thing here in a functional context is that you can think of these successive functions often as operators, successive operators almost on a pipeline, where, for example, F might, the first function applied here, might return a collection. And then G applies to that connection subsequently. Following G, H is applied to that collection, and as a result, you get out some final result. So in this context, what we have is essentially a pipeline joined together by what's known as composition. So we have H applied to the results of G applied to the results of F. And another way, of course, we can write that in a more traditional functional way is H applied to G applied to the results of F, and this would be in a sort of purely functional way. There might be some arguments at each level. So here we have a sort of a mathematical style of application where we first apply this, then we apply that, almost in a sort of algebraic way. And it turns out that for reasons we'll get back to probably at the end of today's class, we're going to see that this allows us, this ability to compose things in that way, provides some very real performance advantages in terms of supporting optimization, supporting parallelization, etc. So we're going to see how that plays out at the end of today's lecture when we talk a little bit about MapReduce and its use more broadly within the parallel programming context. Okay, great. Okay, so why don't we get started now that the AV stuff is all sorted out. Can anyone get the lights? Maybe Arlen, you could just hit the lights on the left there. Oh, okay, well that'll be exciting. The other complement of that. Yeah, that's good. Be a little bit less washed out. This projector is getting old, and the lamp, the solid state electronics that put it out is not so great. Okay, so this is what I had for that, and I'm really interested in seeing some of the other solutions, like the recursive solution. I don't view mine as particularly privileged, but it was an easy way to do it. So for reading the input, I opened the file, I read it, and then I split the lines up. So I divided it into a set of lines by virtue of that. So now instead of just being one long stream of characters, it's been split by the \n's into rows. And then what I did is I mapped over all these lines, I mapped a function that did what? What does this function do in Python style? Remember what this if-else construct is? What does that translate to in JavaScript or Java or C or C++ or Objective-C? What does this translate into? What sort of operator? This is an expression. And what does it translate to? There's one all the way through 0 there. It's the ternary operator. So if I were to write that in JavaScript, it would be something like if char encoded equals star, and then what would I put for the ternary operator?
Question mark.
Question mark, thank you. Okay, good. And then 1, otherwise 0. Basically, this is an expression for, it's kind of an expression form of an if as compared to a statement form of an if. An if statement does two different things. It performs two different tasks if this thing is true. This returns two different values if this thing is true, right? So this is used in an expression context. And I did that, in the context of this, these characters here, the 1 through 0. But of course, that's embedded in a lambda expression. Why is that embedded in a lambda expression? What needs the lambda?
The map.
The map function. Map needs to know, okay, what's the mapping? For each element of this array, how do I map the current value to another value? And that's what that does. So I map these things over each line here, and that line is in turn within another map. So I'm not expressing this well. There's an outer map and there's an inner map. The outer map goes through each line of lines. The inner map for that line applies this character mapping to each character in that line. So outer map, inner map, you get out a result, and then you reshape that into 100 by 100. Now, I have some critiques for this code. I actually think it could be clearer. Throwing out two successive maps is recommended by brevity, but not by clarity necessarily. I probably, on retrospect, would separate these into two separate lines, but it's not horrible either. So I'd probably put in comments for sure. But that works, and it gets reshaped into a 100 by 100 NumPy 2D array. NumPy is numeric Python. Okay. Any questions about that? you notice the Fluent Style here. So open this, gives you a file. You read the file, gives you a bunch of characters. You split the lines up, and it gives you a bunch of lines. So successive application of functions, composition of these functions successively to yield a result, and the same thing in a nested sort of way here, with successive maps going on and then a reshaping. Could be cleaned up a bit, not horrible. Okay, write output. Okay, so I open this file as a write. By the way, well, we'll come back to something that unites both of these things. Okay, here I open a file with write. I go through each row within a count of rows of this space, and I basically join up the characters produced by this mapping for that row. And the mapping for that row basically gets the contents of the row as ones and zeros, and it maps it according to this rule, turning it into space or star as to whether it's the content of the patch is 1 or 0. And having done that, having turned this row of ones and zeros into characters, I join them together, which just concatenates them, and that forms my row, and then I write out that row. Not terribly functional. I didn't require this to be done in a functional style, but I'd love to see functional versions of it. This is iterative. It goes through each row, but there's functional components here. Any comments on that? What is this missing as a very important component besides preconditions, post-conditions, comments, all those sort of good things? What else is it missing? There's a big, ugly elephant in the room. Well, okay, that doesn't sound nice. An ugly elephant. There's an ugly thing rearing its head behind here, and it's not just the prof. What is it?
Magical numbers?
Okay, there's magic numbers. Yeah, there's you could critique that. For example, I've hard-coded how these things are encoded as ones and zeros, and maybe more to the point, as stars and spaces. That's littered through my code now. And if someone said, well, could you use another encoding, it would require searching in my code and finding these things. So fair enough. That's a little bit of a critique there. Yeah, and certainly this magic number up here, 100 by 100, right? That's just like it's crying out for fixing. Okay, so that's good. Yeah, other things? After all, this is count rows down here. Man, I should be flogged with a wet noodle or something for doing that there. Should be count rows and count columns. So that's good. Others? What else is missing? Begins with an E, ends with an R. It's fairly rare that a English word of length 5 has 3 R's in it.
Error checking.
Error. It has to handle an error. Yeah. So what is it not handling?
Errors.
It's not handling errors. Yeah. And partly the reason I didn't put that in there was because I wanted to show you something. I haven't introduced filter and map and reduce yet. And actually, there's a really sweet way to do this using reduction that you can explore. But fundamentally, I didn't want to use an operator I hadn't introduced yet. But I mean, this doesn't handle errors, right? It doesn't handle a case where there's another character besides star and besides star and something else, and it's not even checking that something else is a space, etc. So I mean, that wasn't my point here. My point was to sort of show you some elements of Python, get some illustrations going of how you could use map, and to talk about this. The reality of the fact that when we're writing in a language like Python, or we're writing in a language like JavaScript, or we're writing in a language like Scala, or like Java 8, we often will be weaving paradigms. I mean, this is not purely functional. It could be done in a purely functional way, in a way that would at least make my heart leap. But but I chose to do this in a way that wove together, a couple paradigms, and that could be critiqued from a purist perspective. But this is the reality of pragmatic use of parallel of functional programming. My goal here is not to turn you into, folks who live and die functional languages. I'm not seeking to make you knights of the lambda calculus, as admirable as that order is. You can go read about it online. But I'm seeking to expose you to these operators because they can clean up code that's written in a variety of paradigms, and so that you can use them artfully when it helps, but you can fall back on other operators when it seems clearer. So I'm not trying to make everyone join the functional language crusaders, but I'm hoping to help show you how functional languages can be used, or functional language constructs can be used in a multi-paradigm context. Okay, any questions about this? The first problem set will use this code. You can clean it up a bit before you use this. But you can use code like this, the code that you were struggling with for today, or that you produced in fine recursive form for today. You can use that in your problem set, and you should. But there'll be other components of it as well. I'm asking you to write it in the first problem set, rewrite the code in a style that is kind of similar to its original style with two different arrays. And then I'm asking you to do it in a more traditional functional way, where instead of having two different arrays, writing to one, writing to the other, you're using functional style, where you take the next array is just a function applied to the last array, and the whole mapping of spaces is done in a functional fashion. So that will be the key part of the assignment, and this Python is going to be how you encode it. I should note, a lot of these examples I'm going to be showing you, I used to do in this class, not this particular one, but a lot of the things in the slides in JavaScript. JavaScript has pretty good support for functional programming as well. And if anyone's interested in a JavaScript sort of versions of things, I could show you them for a lot. Any discussions, questions, comments on Python as a language? No? It's spare as a language. Not a lot of types, littering it. Not a lot of extra characters to indicate scoping. How is scoping indicated in Python? This will be an important thing for you to know. Indenting. It cares about indentation, which in my mind is good because I've seen a lot of terrible indentation. And the fact that it enforces some sort of indentation is probably, well, at least it will spare certain atrocities in the form of code style. But you are required to use indentation, and because of that, we're freed from the tyranny of curly braces, which is not a bad thing in my mind. Python is also free. So who was it? Alan Perlis, head for a while of the CS department at Yale, and an important contributor in the early computer science community. He noted that syntactic sugar leads to cancer of the semicolon, and this is free of cancer of the semicolon. We don't terminate lines, or for that matter, separate lines, per Pascal tradition, with semicolons. We can do without some of that cruft that often creeps into our programs. The lambda syntax is admirably concise compared to something like JavaScript, where you actually have to say function of paren, put it around the parameters, and then you're going to have curly brackets and stuff like that. So it's quite spare as a language, and not bad because of that. Python has some trade-offs, and as time goes on, we'll try to talk about some of those trade-offs. they don't all fall one way or the other, and some of them are very arguable if they're a benefit or a liability or both. In many cases, it's both. Okay, Python. Good for functional experimentation. Good language to know. A lot of good stuff is written online in Python. The Django framework is great for web-based programming, and a lot of things to recommend this language in terms of libraries, and some shortcomings we'll talk about later. Okay, any questions on this? Okay, so let's get back to our main point of note, and I'm tempted to stop